morning, everybody. It's great to be here in Johannesburg. Today, I am going to talk about writing Python code to build a Django application that helped tally the votes in the Libyan election. I'm from ONA. We write software that works on similar problems. And this project was in collaboration with the High National Elections Commission in Libya, the United Nations Special Mission in Libya, and the United Nations Development Program. They all get a lot of credit for helping make this a successful project. On the right-hand side, this is Dix Nukanga, who is the co-lead on the project and is a co-founder of ONA. There's no way it would have got done without his help and his tireless work. So the problem. So the goal of this talk is to sort of like talk about writing software, tools, techniques under like a stressful environment when your deadlines are tight and the problems, if you mess something up, are really severe. So how do you handle that? What type of tools can you use? How can you sort of structure the way you're approaching what you do? So the whole thing started with these boxes. These are bins of votes that have come in from across Libya and across the world. Some of them have been driven from different places in the country. Some of them have been flown from England, from Texas, from other overseas places, from Australia. Some of them were even helicoptered in from an offshore oil rig. And these contain different satchels, which contain paper ballots, which contain actual votes. And we wanted to turn these boxes into some sort of list showing how many votes each candidate got in each election. And we wanted to be as confident as we could that these numbers were accurate. So to do this, to turn those paper ballots into some computed results, we had a bunch of workstations in one tally center in Tripoli, and these were going to be manned by clerks. They were going to use our software to tally the votes. So putting this into words, we wanted to tally many votes from many elections in many districts. And another thing we need to account for was that the elections may span multiple districts. I'm bringing this up because this is an interesting point that we didn't know at first when we built the system. And that's going to happen whenever you build something. So each ballot in the system goes through a 7-stage verification process, and our main responsibility was building this 7-stage verification process. It starts with intake. That's when somebody opens a box, opens a bag, takes out a piece of paper, looks at the numbers on it, and enters it into the system. We now know we have it somewhere, and we want to start recording the information in it. Next, we move on to data entry, which happens in 2 steps. One person takes the paper, they enter the votes into the system. That goes then to another person, a completely separate person in a different room. They look at the paper again, enter the votes again, and we have 2 versions of the data in our system. Now we move on to a corrections person. If there are any inconsistencies between the 2 entries, somebody sees the 2 different entries, they have the paper in front of them, and they say, this is the correct one, or if this is the correct one, or something's wrong, something's very wrong, and they send it back. After that, there's a quality control stage. So corrections is skipped if the 2 data entries are equivalent, and if they aren't, it goes to quality control anyways, in which another person in another station sees the entered data, compares it to the paper, and makes sure that the representations are equivalent. And assuming all of that happens well, it goes into an archiving stage. So archiving passes it through some internal checks. So some basic things is the number of votes less than the number of registered voters in this district. If that's not true, then there's some sort of problem. It needs to get further analyzed. If that's true, they print out some covers, it goes into a filing cabinet, and ideally we would never see it again. But of course there are exceptions to that. So that was the main problem for the software. The other problem was that we had 3 weeks to build this whole system in. And 3 weeks sometimes that's a long time. Like, for a problem you're working on, you can do it in the night, right? Like we're all willing to stay up if we need to, but for something where you want to be sure, and when it's going to affect the people who are going to be deciding the constitution in a country, 3 weeks is a very short amount of time. And this is a chart showing the number of commits per week on the project. So that's about half a week there, and then the election was this week, half a week into this week. So we're very glad that that arrow is on that bar and not on any of the previous bars, because, that's a problem. So given this really constrained timeline, we talked to our partners, we sort of explained the challenge of doing what they were asking us to do, and had them focus and came to understanding that there was a need to focus on only getting the essential functionality done. This is the stuff that we were definitely going to build. There might be other things, and we might build those, but what did we need to build? What functionality must exist? What could they not compromise on? So we had lots of discussions over a short period of time to get to that core. And then we figured out, once we sort of knew what that was, what tools already do this? Where can we avoid writing code, and what can we use to get things done faster? And we considered, what are we going to do if we miss something? How can we build the system so that when we inevitably leave something out, something gets confused, somebody explains something in a less complete way than necessary for us to build what is required for it, how can we change things without breaking anything that already exists, without having us slow down, without corrupting any existing data? So with an understanding of the problem and an understanding of the core functionality necessary to address it, we built a schema. And we built a schema not to serve as much as a database representation, although it did that as well in large parts, but to more serve just as a tool to communicate with all of the partners and have a shared understanding of what we were building, what would be possible in it, and what we were excluding as possible, or assuming we wouldn't need to represent. So this would decide how the data is organized, and it would also make some things impossible. Like we couldn't have an HABTM relationship between results forms and quality control forms, and that's something that we could show to our partners as like a concrete thing where we're not planning to build. We might not show this to them, but we can explain it through this, and have it be clear that if this is something that we need to build later on, this wasn't something we were going to build originally, so we need to account for that. And this could also serve as a tool for our programming partners, and a shared reference for all of us to say, do you want to extract data from our system? This explains how the data is organized. This is the structure we all agreed upon, and this is the definition of the problem. So it scopes possible relationships, and when we need to change it, when we need to account for something new or add a feature, we can update it. So we have our problem, we know the core functionality, we have a representation of the data, and now we can start figuring out what we need to do. So we convert all of these discussions into issues, into small chunks of work that we can get done, and into small separable chunks of works that can be made into like isolated modules. And we figure out how those modules relate to each other, what depends on what other modules, what is higher priority, what can we get done sooner to show them something that they can then critique, that they can then tell us we're on the right track or we need to modify or change our prioritization. And at every step, we'd communicate with them and describe the issues that we were working on, why these were important, and how these related to the future functionality. So once we have this, we can just start doing it. So we take our issues, we assign them, we write tests for the issues, and the writing of tests first helped clarify what the issue actually was often, not just to help us as programmers in this ideal where it's test-driven, but to also describe what are we getting done? What are some edge cases that we haven't thought about? I write code for the tests, which usually leads to more edge cases, which usually leads to more tests, and which usually leads to changes in the tests. We'd issue a pull request. We'd do code review. We'd make sure it passed the continuous integration system. We'd merge it, and we'd go back to step one and just repeat the same cycle over and over and over again until it's all done. And for each of these issues, and for each of the tests, we're trying to automate speed. So use tools and use processes that will make us go faster, make us not have to repeat things. So anything that we did twice, whether it was setting up a database, changing permissions, like running some building some initial demo users, that would all go in a script. It was mainly a bash script. It might have been a Python script. It was, for this use case, just whatever we could write down. Some of these scripts wouldn't be used that often, but having a record of what had been done and a reference to say, this is the library of things we have done for this project was extremely useful and gave us a record of how we could do it again without having to think as hard about it the next time. And of course, anything that breaks, when somebody reports a bug, when we see an issue, when something isn't as expected, we write a test for it. And we are more confident that it won't break next time. We're never sure, but we can be more confident. So speaking of things we do over and over again, database migrations. We do that all the time. So we use South. It is great. And this solves our automating migrations, automating problem. And it also solves our not writing code problem. So all of this code, the schema, was something that we didn't write. We didn't have to touch it. We never had to modify it. South did all of that for us, which is what we want. We don't want to have to write code. We're programmers. If we can get a computer to write code for us, that's better. We have more important things to do. We use Postgres for our database, and Postgres was sort of essential for this because the guarantees on consistency are much higher in Postgres than they are in other databases. And this is a small script that we use to build our Postgres database. And this is not the first version of the script. The first version of the script probably took only one argument, which was the name of the database. And that was fine. We just want to get something up. And then over time, somebody's like, oh, well, we need to actually run it on a specific IP, so we'll add this argument, we'll have to add this argument, but we didn't worry about it the first time. We just worry about getting something that's going to help us move on and not lead to any unrepeatable work. We also use Postgres for replication. So this is a big script that set up the replica database. All of our data was replicated from one main application server that users were interacting with to a separate server that just duplicated the data. And that separate server would be responsible for doing database dumps so that we could store our database incrementally and guarantee the state of our data in case things started getting iffy without interrupting users that were using the system. So you could have people, and we had about 150 people entering data, so it was around 100 concurrent connections probably, sometimes a little bit more, a little bit less on this local network, which is, it's not a lot, but this gave us the guarantee that we could store our data without having to worry about our concurrent users. And another useful automation tool was we use nose for testing, Django nose specifically. We used Flake8 for style checks, and we used coverage to check our code coverage. We didn't use coverage that frequently, and we didn't automate it. Maybe we should have, but it gave us, more confidence that we were covering a larger part of our code and that our code wouldn't be breaking. This test is a style test, so if your code was not Flake8, it would fail on continuous integration. It would be red, nobody would merge it, and we would just put a guarantee on some consistency in the actual code that got in there. And this is very useful. So it was this extra check that people had to think a little bit harder when they were writing stuff. If we could have made this more stringent, I would have. And if you can think of ways to better check style, do more static analysis through tests, that would be great. And we use Travis for our continuous integration system. So we didn't use Travis at first because our code was private, and that was a bad idea. Don't not use the continuous integration system. So we could have used Jekyll, we could have used Drone or some other system. Just the value out of seeing red, green, knowing what tests are feeling, having that shared idea of code state and code quality is super valuable. But more important than all of this was that you don't want to write code if you don't have to. We did everything we could. We looked at all of the libraries we could to avoid writing code ourselves. So unless we really, really had to, we would not do it. And this is like a lot of our ability to not write code is thanks to the great PyCon ecosystem. So this is an excerpt from one of our views that uses Guardian. So we get permissions and all of that without really doing much of anything at all. So this is a template view. The mixin group required, I'm pretty sure Conga wrote that, validates against Guardian, and the group required class variable there defines what groups can access this view. So all of that permission checking, all of that is stuff that we get for free from Guardian. Another library we used to avoid writing code was enum field. So enum field provides different states, so we can check what state our form is in as it passes through that very, very obtuse flowchart. And we can also encode transitions with enum field. So this will raise an exception if we change state from one state to another state that doesn't match the defined transitions. So this was incredibly useful for us as coders and for communication with our partners. So if somebody came to us and they were like, this form was an intake and now it's an audit, like your system's broken, like somehow it just went to audit. We can be like, that's impossible. That couldn't have happened. So like we built our system to make that impossible. Let's just look at the database, let's see what's going on, let's look at our logs. But being able to confidently say that something is impossible is super valuable. And being able to explain, this is a encoding of the transitions. So something that's in audit can only get there from that set of states. Something can go to archive, so that's the final state, can only go to archive from being in archiving or in audit. So we can, we know that the results that we're exporting when we're saying this is the number of votes that this candidate got are only in forms that are in this archive state, and we know that they've only gotten there by being in these prerequisite states before that. So in addition to that, being able to show our partners how things have been changing in the system and being able to go back in time in our data was also something we really needed to have. And we used reversion to do that, and that gave us, as close as we could with Python, or much closer than we had before with Python, a pure view of our database. So every time we changed our data, we would reversion logs a serialized version of the previous data. So in that same situation, when something looks like there's some problem or somebody comes to us talking about some bizarre thing that's happened, we can pull up the history of the data and show them exactly the different states that the data went through and why that happened. We can say how the data got to this unusual state that it happens to be in, and we can figure out how it got there. And a lot of that, it gives our partners, people we're working with, confidence that we can control the changes that are happening in our data, and when they change in unexpected ways, we can explain those unexpected changes, and there's some recourse to remove that possibility of unexpected change in the future. This is the one line that gives us that data purity, thanks again to the Python ecosystem and open source software. On the other side of automation, like bringing together all of the scripts, who here is familiar with Fabric? Fab files, yeah, Fabric's awesome. Um, and there are other awesome things too. Those might have been better. We didn't explore them, like Ansible, Chef. They may have been appropriate. We went with Fabric. We knew it better, and it allowed us to automate our deployments, automate running bash scripts on the server, automate setting up the replicas, automate running migrations, running management commands, automate like background tasks, all of that. Every time we would SSH in the server and run a bunch of commands and then forget what we ran, we would write down those commands, put them in a bash script, and then refer to that bash script using Fabric. And maybe we'd convert it into some prettier format like this where we're actually running a Python command. And this is a bash command right here. But we might combine them with Python code if we have a need to abstract them, but we're not worried about making it that abstract. What we're worried about is just making it reproducible. And so this automation gives us a way to plan to handle what we have not planned for. So it gives us a way to deploy new changes to our code to a learning system and still be confident that we're not going to damage the consistency of the data and we're not going to interrupt users. It gives us a way to make changes to our data model and know that we can make a change to our data model, then flow it down through migrations and code review and CI, and not have to worry about having messed up any of the other functionality that might be running on a live system. One of those things that we didn't plan to handle was the elections, that elections can span multiple districts. So we found this out the first day of live testing. So this was before the election happened. This was, I think, 2 days before the election happened. Yeah, Elliot remembers that. That's fun. So this wasn't like, it's not like this was anybody's fault that we didn't know this. The data wasn't described that clearly, and we didn't have enough time. So, what we did when we found this out was, all right, well, let's figure out how we can accommodate this. And we had a plan. So we changed the data model, and then we changed the database using self-terminal migration. We wrote tests using Django Nose. We were pretty sure that we weren't breaking anything else. We changed the code, had it run a build. We're even more sure that we didn't break anything else. And then we used Fabric and we deployed it. And we put this deploy in the production system. I think it was around noon on the day of testing. We found out about it around 9. And no hiccups, thankfully. Not that there weren't hiccups in other ways, of course there were. Often the hiccup was that it's going really slow, and we don't know why. And there's this one computer that's going really slow. And it turns out that one computer has a bad connection to the internal LAN that we're on. So things like that, we would respond with, okay, let's test it from another computer. Let's validate this in some way. If it can't be reproduced, it's not going to be something we really need to think about. It's going to be something somebody else can think about. So on both the code side and the project management side, we just tried to make everything as simple as possible to solve our goals. So simplicity is a prerequisite for reliability. The less code we're writing, the more we can rely on well-tested libraries that have solved this problem and in which other people are using those same libraries that solve that problem for them, the more confident we can be that our use is going to work out. Like we're going to build on the confidence that other people have established the code changes that they've made over months, more often years, to guarantee that it's a simple, reliable implementation. So in our data model, a lot of that simplification was figuring out how to explain relationships in a way that didn't refer to the esoterica that was only relevant for us. So that that big schema is complicated, but it's actually like we understand it more simply through maybe the way you'd express it in a model as a has-many relationship. Explaining a has-many relationship is not that hard. Explaining the nuance between the indexes needed for has-many relationship is a little bit harder and is not necessary. Okay. So I'll mention some of the references that I referred to. We used South for database migrations. We used enum field for the transitions. We used Fabric for deploys and automation. We used Flake8 to check style, to do very basic static analysis. And we used coverage to run coverage. All of this code is open source. And its being open source is what made it usable and what made it helpful for us. If you can find a way to make the code you're writing open source, or advocate for it being open source, or for libraries in it that you think are useful or you think would be useful to other people to be open source, please do it. It's so helpful. And open source code is just higher quality because you're forced to think about how other people are going to judge your code. And this also gives a chance to read through other people's code and say, oh, this is how somebody's structuring this thing. I mean, reading code is something that is often neglected because, I don't know, it's time consuming. It's maybe a less direct way to understand code. But we got a lot of value out of that, and I believe there's a lot of value in that. The tally-ho system that we built, which is what I've been talking about, is all open source thanks to the HNEC, the High National Election Commission's permission. And you can learn more about ONA at ona.io. So this is our team. We build software that is used around the world to solve international development and humanitarian relief issues. This is about half of our team. That's me in the middle. There's a waterfall on the left-hand side. If you want to write software with us, come talk to me. Thank you very much.
Thank you very much, Peter. I'm sure we'll have some questions for you. I've got one to start with. When you explained to the partners that you're building the system and it's all cool and you're going to use this thing to do something, but don't worry, some guy on the internet wrote it. I don't know him, I've never met him, but he has his website and I'm going to use it in this system that is counting votes. Did you get any kind of strange looks from anyone? Was that a part of the process for due diligence, or did they just sort of accept that you guys knew what you were doing and would trust you?
Yeah, in general, they were accepting of that. They didn't really push back on any of the libraries we were using. And the way we couched it was more in terms of, this is something that we believe will work based on the fact that we're using it and it's passing our tests. It might be passing their tests, but the tests that we have written that I guess they're more functional tests at that level then, since they're testing that functionality. Those pass, so we can guarantee to you that the way we're using their system is correct for the problem we're solving, even if we can't guarantee that we wrote it well. We didn't have the need to argue with them or to convince them that we could use it. Yeah.
Cool. So, any questions? Someone's got a question. Right back there. Do you want to shout and I'll repeat it for the... Cool.
It's a non-technical question, but I was just curious. You said it was a pretty intense project. Did you ever have like an 18 or 20-hour day where... oh, there you go. It was a pretty intense project where you had to do things quickly. Did you ever have like a really long day where everybody just had to come together? Do you have an anecdote you'd like to share? Share the anecdote whether you want to or not, okay?
Yeah, we had some quite long and quite stressful days. It was also a unique environment because of the security concerns. So I don't remember which day this was. I think it was around when the votes had been. I think it was the day after the votes had been collected, maybe. So the system was running. Oh, I guess okay. So maybe this is definitely the most stressful experience was when the system had been running for maybe about a day or two, and there were enough votes that we could export results and say that these were the results. So they would take our exported results And they took our export results, and then they went into the archive and then pulled out the paper and just wanted to, like for a small subset of them, they looked at the paper and counted up manually with calculators and whatever to make sure that those votes were matching the results our system was exporting. So while that was happening, I just left the building and went to another building and waited and then came back. And thankfully, it all matched up. But most of the changes that we had to make were more around the user interaction and the more stressful parts. Other than that, just okay, it works. Thank goodness. The changes that were about like nuances to user interaction that weren't thought of beforehand. Like in the clearance section, maybe somebody wouldn't. Maybe even the text description on a button wasn't clear enough, or the placement. So the challenges were more around not having had the time to completely think out the user experience. And that, if we could have more time to do one thing, it would be to do more prototyping and testing on the user experience side and the UI side. That would have saved us time.
Cool. We have time for questions, so if you've got one, shout. I'll ask one more. Where is the data now?
So the data that was collected?
Yeah.
The raw data is private. Yeah. So that's in Libya with HNEC. So the results of the election, the exported versions they should be on the internet somewhere, but they should also be like on HNEC's website. So the data was not to be made publicly available, but the code is.
Cool. Here's a question.
Concerning data integrity, I see you got reversion, or whatever it is. It looks like a great piece of software, but obviously you have to now ensure the integrity between the database and the code in the front end to ensure everything's gone through the audited process. Did you write management commands, use worker processes? How do you accomplish that?
Yeah, so they gave us two gigantic, like 64 gigabyte RAM servers, so we didn't really have to worry about background processes, which was very nice. So the main things we did to ensure the integrity were the state machine transition encoding, and for all of the user inputs, form inputs, we would check backend sessions against submitted data. So when you would log on, we'd persist some session on the backend, and on every form that you submitted, we'd also have that encoded in the HTML, so that if you were like messing with the page, we could know that something had changed between the page we presented to you and what we were expecting back. But like honestly, that wasn't that big a concern because we didn't, the clerks who were entering the individual data weren't that big a security risk. Our system was on a private LAN, disconnected from the internet. Yeah.
Sorry, did you have rogue entry people, or is that just this? You're saying that was a scenario you accounted for?
We accounted for it. We didn't have any.
Next question.
How long ago were the elections? And if you had to do it again, would you swap out any pieces of the stack or any of your automation tools, and why?
Yeah, so the elections were on February 25th. I believe, okay. 20th, February 20th, thank you. I don't, yeah, it was a long 5 days after the elections. Yeah, our stack was pretty solid. Our biggest challenge was in exporting. So we didn't, exporting we built after the system, since that wasn't, once we had the data in and we wanted to verify its consistency foremost, and then would build the exporting. So I would add something to do more batching for the exports and to do that in a more formulaic way. It was sort of just thrown in. But the actual stack that I presented, I think was solid. There are some tools, alternative tools that I don't have enough experience with that I think should be tested out, like using drone for the CI. That would be interesting. Using Ansible for the DevOps stuff. I think there's definitely better ways than writing bash scripts for a lot of the server setup. Yeah, the main things.
What was the result?
42.
So that chart that I showed, these are the actual results. So for some of the elections. So yeah, so you can see that Al-Hadi Ali Yasif Abu Hamra won in the first one. I'm sure we can all see that. Yeah. So it's, and these are the people who became the Constitutional Assembly representatives. So these weren't elected to parliament. These were people who would represent their various districts in figuring out the Constitution. Yeah. And there ought to be more results on the HNEC website. But I think maybe more of the value out of this was the open source tool, which was later used in another election that was held in Libya and is planned to be used in a further election whenever that happens. So we got to do some of the work in building like a generalized election system. That's like the dream, the sort of goal is to make this more abstract and have it be generalized and have it be sort of just pushed out as something like that. A lot of the election software that exists is closed source and run by private companies, which is absurd and doesn't make any sense. So anything that we could do to help make election software open, we're happy to do.
This is more about the business side. That last statement you made, a lot of the election software out there is closed source. How do we go about getting this type of software more generally used? What are the barriers for getting countries to choose open source platforms for elections?
Yeah. I think the reason that this could be built was because of the context in which it was used. So software that records votes that are on paper and puts them into a system there's not as much of that out there. So maybe starting with that and sort of showing that as a way that election software can be written that is consistent, you can sort of verify that it's valid and make it public and have good results is sort of a way to start. For like larger elections that involve electronic voting, that's harder and that's outside of my domain of expertise. But I've from talking to friends, definitely one of the ways that they've gone about trying to make election software open source or advocate for it is showing the really significant problems with using closed source software, exploiting voting systems, just saying that this is all of these systems are exploitable, and a lot of that has to do with the fact that the software was written poorly and nobody's accountable for it. When it's open source, at least somebody is accountable for it. So break election software, hack it. That's my suggestion.
My question, yeah. This side, sorry. So you say you used clerks to input the data. Did you guys ever, was this a requirement from your contractors? Or did you ever lobby to use like an automated system to like track the votes where you could like guarantee a 99% accuracy and then just have human intervention for the 1% that might be off?
Sorry, so that might have been somewhat misleading. So the tallies that we received weren't the actual ballots, they were summaries of the ballots. So the ballots that people filled out in a polling center, in a remote polling center, were then like summarized in a like results sheet, which I don't have a copy of right here. And the results sheet would show the number of votes for each candidate, not by a specific individual. We talked about ways to use mobile data collection to get the data in faster, and maybe to do a little bit more verification, although it's not necessarily, it's hard to see how we could do that. Yeah, and I think that's something we want to use in the future is using a mobile form to get this data in. There are like much more advanced systems out there that do this in other countries. But I guess this could handle all of those odd cases where you can't distribute a phone or your voting's happening on an oil rig and there's no way to get the connection back, get the data connection back. So it was more about being broad and covering all these cases that we could potentially see.
Excuse me. Just something that third column there, stations percent completed. Am I right in saying that that is the second column divided by the first column as a percentage?
Yes.
Okay, because halfway down there, there's one row that you've got 183 ballot number and 183 stations completed, but only 99%.
Yeah.
So, what's
there are
what's that
two
about?
things that could be going on here. Yeah, no, I think what this is this is probably one of those cases that spanned multiple districts, one of those like special elections where the numerator is not being calculated accurately, or the denominator, one of those values is not being calculated accurately. And like I don't really have a problem with that being wrong in this intermediate version of the output.
Okay.
But yeah, so like that's great. That's an example of one of the problems that we would see, and we'd go back and be like, okay, well now let's wrap more tests around like our export generation code, and let's figure out why this is wrong. But that's probably what's causing this. The other thing that we had to deal with was sometimes they would close an election station and like want us to sort of change the system to change the number of stations somewhere but not everywhere, and you know that could have also affected this, but I think it's less likely that that's the cause of this case. Yeah.
So can you tell us if you encountered any challenges with non-alphanumeric right to left text like that? I mean that.
Yeah.
I mean that looks like it was pretty tricky to get right.
There are libraries like for CSS, right to left, that we use, so those handled all of that for us. And it's all UTF-8, so like on the back end, it wasn't a problem, except Excel sort of freaked out when it tried to look at it, but you know, that doesn't bother us. But yeah, the libraries do right to left without a problem.
Okay, I go on one question and then one more, and then we can probably do another question after that, but then we're going to be done. So my question is, assuming you could have been a baddie, who was watching you? Was there another agency that was looking at your code and making sure that your team wasn't all corrupt?
Yeah, so as I was writing the presentation last night and thinking about conversations I had about people, you know, they look at this verification process and it's like, oh, this is so complicated. Like it's really hard to get anything past that. That was the weak point, was the developers. Like the only person who could get something past this was Dixon and I. So the answer is no. There wasn't anybody watching us. Yeah, there should have been. The code's open source, and the production code wasn't open source, and they were doing the manual verification, which checked some of that. So those were like the things that were done to address that. But you know, it's hard to figure like what's the solution for this. Maybe there's a consortium of individuals who validate the software, or they look at the running software, or they're just monitoring it, or maybe there's some way in which there's like some insight, there's some like view into the data so that changes that look unexpected are somehow flagged, or yeah. But it's also, I mean, the expertise you'd have to get experts into to be doing that validation.
Cool. I've just got a quick question about your usage of South. Did you guys encounter the issue where you have two separate feature branches with migrations which end up sort of, conflicting? Not necessarily conflicting, but obviously they consume the same numerical slots that South uses. Did you guys encounter that? I'm just interested to know.
Yeah, I don't think we encountered that with this project, but we have on other Django projects that use South, and one of the branches would get rebased and have to rebuild their migration.
Yeah, that was fun.
Yeah. But interactively rebased, so it's a little bit fun.
Does anyone else have a question? I have one more volunteer right here. No one? Simon's got a question.
What's the next feature you'd like to see added to Talio?
it needs more UX love. That's what it needs. It needs more testing, like with somebody who knows a lot about UX sitting next to a clerk who's doing each of the stages and watching them intensely and like noticing where things are getting confusing. That was the main weak spot, was just not having enough upfront time to develop the UX, having the UX be like, oh, this should work. Yeah, that makes sense to me. Okay, this is going to be how we're going to implement it without having seen the live user interaction. That's what it needs.
Okay, one last question, and then it's tea time.
So I just quickly want to know, how much research did you guys do up front about like other systems and how that influenced like your decisions on building this?
So there was a voting system that solved the same problem that was built for the Afghani elections, and we read the design documentation for that and were walked through the whole process by one of our partners at UNSMIL, and that was the main piece of research. We discussed with some of our friends who've done voting software hacking in the US about like some just data security issues, but that was mainly all we did. We could have done more if we had more time. It would have been great to do more. That would be another nice thing to do as the system gets further expanded.
Cool. Peter, thank you very much. It was a very interesting talk.
Thank you all.
And